All right, number 7. 5 to the x equals 25. Math common sense. All these are no calculator. You're not allowed to have a calculator. So you just ask yourself what to the x power. It's going to be x equals 2, right? 5 squared is 25. 8. 7 to the x plus 2 equals 1. So again, math common sense. I can't use a calculator. So what am I going to do? I just simply need to know that 7 to the what power is 1, right? Anything to the 0 power equals 1. The only way I can raise 7 to an exponent and get 1 is if it's to the 0 power. So that tells me that x plus 2 is going to have to equal 0. I've got to have a 0 here, so x plus 2 equals 0. Subtract 2 from both sides, x equals negative 2. Next problem, 9 log base 3, 3x minus 4 equals log base 3 of 7x plus 12. All right, not allowed to use a calculator, so hopefully you see this. I've got a log base 3 here and a log base 3 here. So since I've got both of these the same, I can just set these two things equal to each other. 3x minus 4 equals 7x plus 12. Solve for x, minus 3x, minus 3x, minus 12, minus 12. You can get negative 16 equals 4x. Divide both sides by 4, x equals negative 4. All right. Number 10. Log base 7, 2x squared plus 5 equals 3. All right, so when I only have one log, I can't use a calculator. I'm probably going to have to convert to exponent form. So let's do that. Start with my base 7, raised to the 3rd power, equals all of that, 2x squared plus 5. So 7 cubed is 343. So that's going to equal 2x squared plus 5. Trying to solve for x, so just subtract 5 here. I get 338 equals 2x squared. Divide both sides by 2. That's going to give me 169 to equal x squared. Square root both sides. X is going to equal plus or minus 13. However, when I'm taking logs, I've got to make sure that I don't have any extraneous solutions, right? Can't take a log of a negative number. So plus or minus 13 are actually both going to work because a negative times a negative is a positive. So answer is plus or minus 13. $11. 81 to the 2x minus 3 times 1 over 27 to the 2x equals 190. All right, so can't use a calculator. That's a big key. I have my bases. I should hopefully see that I might be able to get them to a base of 3. I could rewrite them with bases of 3. So that's what I'm going to want to do. 81 is 3 to the 4th. 3 to the 4th is 81. They're the same thing. So I can substitute 3 to the 4th in for 81. And I'll end up with that. Got to multiply the 4 by the current exponent. Then I'm going to have here 1 over 27. I can rewrite that as 3 to the negative 3. 3 to the negative 3 is equivalent to 1 over 27. They equal each other. They're the same exact thing. So I can substitute 3 to the negative 3rd in for 1 over 27. And then I need times 2x. Equals, and 9, I can rewrite that as 3 to the negative 2. 3 to the negative 2 actually equals 1/9, so I just kind of substitute that in there. Now, have all my same bases, but I got a little bit something more complicated over here, so I want to simplify this down to just one base. So when I'm adding, or I'm multiplying two things together with common bases, I add the exponents. When I'm multiplying common bases, I add the exponents. So this is going to be 3 to the 4. I'm going to go distribute the 4. So it's going to be 8x minus 12. And then plus Negative 3 times 2 is going to be negative 6x equals 3 to the negative 2. So since I have one base on each side and they're the same, I can set this equal to this. So I'll get 8x minus 6x is going to be 2x minus 12. So I just simplified this all in one step. 8x minus 6x is 2x minus 12 equals negative 2. Add 12 to both sides. We get 2x equals 10. Divide both sides by 2. X equals 5. Don't need to check for extraneous solutions. Log base 4 of 2x plus log base 4 of x minus 4 equals 3. All right, so no calculator. What do I want to do? I see I've got a log 4 bases, so I can actually condense these things. So that's gonna be what I want to do. Plus, it's going to be the product property. So log base 4 of 2x times x minus 4 equals 3. So now I have one log on this side. I can convert to exponent form. Start with my base here. 4 to the third power, 4 cubed, is going to equal, I'm going to go ahead and just distribute this. So that'll be 2x squared minus 8x. 2x squared minus 8x. So I got 4 cubed equals this. 4 cubed is going to be 64 equals 2x squared minus 8x. And so now, again, I've been begging you guys all year to get this. We see an equation, quadratic equation. You need to recognize it's a quadratic, x squared in an x term and a constant. So you need to be thinking, I'm going to have to factor to solve this. In order to factor, I've got to set it equal to 0. So I'm going to go ahead and just subtract 64 from both sides, and I get 0 equals 2x squared minus 8x minus 64. So, how do I factor a trinomial? First question you always want to ask yourself, is there a GCF? There is. I can factor out a 2. 2 goes into 2, 2 goes into 8, 2 goes into 64. So there's two ways I can say this, if y'all remember. I can actually factor it out, or since it's equal to 0, I can simply divide both sides by 2. It's another way of factoring out that greatest common factor. So 0 over 2 is 0, 2 over 2 is x squared, negative 8 over 2 minus 4x, negative 64 over 2 minus 32. And then finally, factor a is 1, so this becomes really easy. X and x, factors of 32 that are going to have to be 4. 1 of 32, 2 and 16, 3 no, 4 and 8, 5 no, 6 no, no. So 8 minus 4 is 4. So I'm going to need a negative 8 and a positive 4. Negative 8 plus 4 is negative 4. Okay? So x plus 4, x minus 8. 0 product property, set my two factors equal to 0, and I'm going to end up with x equals negative 4 and x equals 8. Last step, since we have logs, I got to check for extraneous solutions. 2 times negative 4 is going to be negative 8. I cannot take the log of a negative number, so that does not work. 8 minus 4 is positive 4. 2 times 8 is 16. We're okay. All right.